Now come to the factor, the K3, the topographical factor, and the factor takes into account the general site above sea level, and this does not follow the local topographical features such as hill, valley, escarpment, etc., which can be significantly affect the wind speed in the vicinity. The effect of topography is to accelerate wind near the summit or hills or crest or cliff. Escarpment ridges deaccelerate the wind in valleys and near the foot or cliffs or steep escarpment. What is the meaning of this? That means during the escarpment or hill, the speed V increases, valley V decreases, and the effect of topography shall be significant at their site when the upwind slope is more than 3 degree. The effect of topography will be more significant if the degree of upwind is 3 degree and below below that K3 is taken as 1.0, and K3 value generally varies between 1 to 1.36 for slope more than 3 degree. A slope of evaluating the K3 values more than is given in the annexure C. It may be noted that the K3 varies with height above the ground level at a maximum near the ground and reducing to 1.0 at the higher level. So now come to the annexure C. So firstly, let's know about what is escarpment and what is hill or ridge. Ridge is actually the peak of a hill or ridge. That means the topmost point. That is the crest of a slope, and this portion is the upwind face, and this portion is a downwind face. We can say this also downwind face. Slope continues. Escarpment means there is the hill and a flat region, and after that a flat hill region. Sharp rise in the slope with long flat region after the crest. After the crest, suppose this is the crest, after that long flat region, this is called escarpment. But in the other case, if the slope continues, then it is called hill or ridge. So during escarpment the speed increases, and during the valleys there is no slope. That means the velocity decreases. Now let's go to the annexure C. And we have earlier discussed that the K3 value is less than 3D if K3 value is depending upon the topographical factor, and the theta is, that means upwind slope, if greater than 30 degree. So we have to calculate the factor K3, and K3 value is generally 1 to 1.36, and the K3 value is varies between 1 to 1.36. So first we have to calculate the influence of topographical features is considered to extend 1.5 LE and 2.5 LE, and we can see that the LE is not known to us till now. So we have to know the value, what is LE, effective length. LE is the effective horizontal length of the hill on a slope indicates below. Let's see what is LE actually. This is in the upwind direction, as annexure C mentioned, in the upwind direction. Suppose this is the source of the wind and this is the upwind direction, it will faces towards the source, so it is upwind face, and the upwind effective length in the LE the influence within this area, the influence of wind occurs in the upwind direction and 2.5 LE for downwind direction. Okay, now there is some factor how to calculate LE. For 3 degree, if theta is less than 3 degree to 17 degree, we calculate LE as L, and if theta greater than 17 degree, we can say Z by 0.3. Z is the effective height of the topographical features. Effective height of the topographical features. That means this is the effective height. And theta is the upwind slope. In case of zone in downward side, the crest of the features is relatively flat. For a distance of exceeding LE, the feature should be treated as an escarpment. That means that means in the downward direction, that means this is the slope, and after that there is a flat area. So suppose this is the slope, this is the flat area, this is theta, and theta may varies to 3 to 17 degree or more. But here we can see, if we draw a slope within this region, the theta is less than 3 degree. So if after the upwind slope, if theta is less than 70 degree, 3 degree, then it is called escarpment. So we can consider this slope is as escarpment. What it is said, in case of zone in the downward side of the crest, features relatively flat for a distance exceeding LE. That means if this value, suppose this is the crest, and this theta less than 3 degree more than LE, then we can see that say as escarpment. The feature should be treated as escarpment, otherwise the feature should be treated as hill or ridge. Example of typical features given in that figure 13. No difference is made evaluating the KELE. How to in local topographical to the site is significant in terms of the wind. In such cases, the average value of terrain upwind the site at a distance 5 kilometers should be taken as base level for wind excess, the height Z, and the upwind slope theta for the features. Generally, the wind velocity increases as the slope increases. That means the wind velocity increases with the height. That means the height of maybe in front of the wind movement, there may be a hill or ridge, or there may be a escarpment. The wind velocity gradually higher, but it is not possible to calculate the precise data within this short length. So that's why the site for a distance 5 kilometers should be taken as the base level from the wind axis to a height of Z, and upwind slope theta for the features. This line actually means the height generally assumes 5 kilometer to get realistic value. Now we already know that theta is equal to theta less than 33 degree to 70 degree. We L is equal to L, and theta greater than 70 degree Z is equal to 0.3. And for calculating the K3, we have to know the 1 plus C and S0, and C as S0 are unknown to us. So C value, and depending upon the theta, the C value also increases. Z is the height of the crest, and L is the actual length with the upwind slope, and theta greater than 70 degree 0.36. And S0 we can calculate from this graph. So to know S0, actually the S0 is the function of x by LE and h by LE. We have to know the x by LE and h by LE value, and from this graph we got to know this. And the negative sign, we will learn that how the negative sign is coming. This is the upwind slope and negative for upwind, and this is the positive slope, negative positive for downwind. And from this picture we can see that the Z is the crest height, L is the effective length. We already know that for the upwind direction the maximum distance of influence is 1.5 LE and 2.5 LE, and Z is the height, and the point where the point appropriate height is h, appropriate height of above the mean sea level where the wind is being evaluated. That means crest height is Z. At this point wind velocity is evaluated, and L is the radius of influence, from where we will get it. L is the factor of theta degree, and LE is equal to L when theta greater than 3 degree and theta less than 17 degree, and LE is equal to Z by 0.3 when theta greater than 17 degree. So we got the h at which point we will calculate the height. That means h by LE we already know. Now x is the crest height. Now x is the crest height. Z is the crest height. So h at which height we will calculate the wind velocity. LE is the effective length. It is the function of theta degree, and Z h by LE. So let's have a clear vision on this. We have to calculate the S0 value. So firstly we have to know h, LE and Z. There is a graph available in this code, that from where we get the S0 value from two parameters, h by LE and x by LE. And what is LE? LE varies. It is actually function of theta degree and Z. Z Z is the crest height above mean sea level. So theta, if theta greater than 3 degree and less than 17 degree, LE equal to L, and if theta greater than 17 degree, LE equal to Z by 0.3. So from this point we will get LE. H is at this point. We will calculate the wind speed. So H by LE we already know. Now X by LE, and X is not known to us. So from this picture we will know at this point we have to calculate the wind velocity. This is the crest height, and this point to this point, that means this is the point we want to evaluate. This is the point, this is the point, this is the point we want to evaluate the wind velocity, and this point is at a distance of x, at a distance of x from the crest. So we can easily calculate. So we can easily calculate x by LE and h by LE. Now come to the graph, and another thing for upwind slope, we take the negative value. For downwind slope, we take the positive value. So now come to the graph. X by LE, this is the point mean sea level, and put the value of x, h by LE, and x by LE. Suppose this is the point, and at this point we get the value of S0. So S0 is equal to 0.05. S0 equal to S0 is equal to 0.05. Now K3 is equal to 1 plus CS, and now we know that K3 is equal to 1 plus C is 0, and C value is actually the function of theta degree. If theta greater than 3 degree and less than 17 degree, Actually, I have written the wrong. The C value is actually function of theta degree, L and X, and theta, L and Z. As I can see that Z, L and theta. Z is the crest, crest height above mean sea level. Theta is the angle of upwind slope, and L is the actual length with the and L is the actual length of upwind slope. So theta degree and C, theta degree greater than 3 degree less than 17 degree, we can take is Z by L. Theta degree greater than 17 degree 0.36. So K3 is equal to 1 plus, if theta degree is equal to 15 degree, so we can say that 1.2 height is 5 meter, Z is equal to 5 meter, L is 15 meter. That means Z by L into 0.05. That means 1 plus 1.2 into 0.33 into 0.05. Now it is your homework to calculate the value of K3. So by this way we can calculate this value. So where the downside slope is more than 3, there will be a large region reduce acceleration, even shelter, and it is not possible to give general design rule to cater in such value. S0 is taken as upper bound value.